A retail chain ships TVs from 3 of its distribution centers, warehouses, to 3 of its retail stores each month. Each warehouse has limited supply. Each retail chain has limited demand. The manufacturer wants to know how many TVs to ship from each warehouse to each store to minimize cost. Each warehouse can ship to each store. Each store can receive TVs from each warehouse. So we have 3 warehouses, 1, 2, 3, Cincinnati, Atlanta, Pittsburgh, with a limited supply of 300, 200, 200, for a total of 700. Each store is ABC, New York, Dallas, Detroit, with a limited demand of 150, 250, 200, and a total of 600. Okay. We have a cost per route. We have a total of 9 routes. Okay. We have from 1 to A costs $16 per TV. 1 to B is $18, and 1 to C is $11. From 2 to A is $14. 2 to B is $12. 2 to C is $13. $13 from 3 to A, $15 from 3 to B, and $17 from 3 to C. Okay, so our decision variables are the number of TVs that go from each warehouse to each store. So 1A is from warehouse 1 to store B. We have from 1 to B, that was 1 to A, 1 to B, 1 to C, 2A, 2B, 2C, 3A, 3B, and 3C. So there's 9 total. Our minimum cost comes from our table: 16.1A, 18.1B, 11.1C, 14.2A, 12.2B, 13.2C, 13.3A, 15.3B, and 17.3C. Okay, we're going to have 3 constraints that deal with our limited supply. Since there's more TVs, there's 700 TVs, more than the demand of 600, each warehouse supply cannot send out all the TVs because there's 700, but they only want 600. So the supply will use less than or equal to. So everything from 1, all the TVs that get shipped from warehouse 1 would be 1A, 1B, and 1C. Okay, that means from 1 to A, from 1 to B, and from 1 to C, less than or equal to 300. The total TVs from warehouse 2 must be less than or equal to 200. So we have 2A, 2B, 2C, less than or equal to 200. The total TVs from warehouse 3 must be less than or equal to 200. So we have 3A, 3B, 3C, less than or equal to 200. There are enough TVs to meet the demand of the 600 total, so the demand for the stores will be equal to. They want exactly the demand. So the total TVs received at store A equals 150. So from 1 to A, 2 to A, 3 to A. The total TVs received at store B equals 250. So 1 to B, 2 to B, and 3 to B equals 250. The total TVs received at store C equals 200. So that's 1C, 2C, and 3C added up together equals 200. Okay, now we're ready to go to our Excel sheet. Okay, remember all decision variables more than 0. Okay, we have 9 decision variables for each of the routes. Okay, so our cost equals 16 times 1A plus 18 times 1B plus 11 times 1C plus 14 times 2A, 12 times 2B, plus 13 times 2C, plus 13 times 3A, plus 15 times 3B, plus 17 times 3C. Okay, our supply, okay, these are our 3 warehouses. Warehouse 1, 2, and 3, and they have limited supply. Okay, so this is going to equal 1A plus 1B plus 1C, and that's less than 300. Next, supply for warehouse 2 equals 2A plus 2B plus 2C, and that's less than 200. Warehouse 3, the total TVs would be 3A plus 3B plus 3C, and that's less than 200. Okay, these are the 3 stores, A, B, and C, and they have limited demand. Okay, so this equals 1A plus 2A plus 3A, and it equals 150. B, 1B, 2B, 3B, and that equals 250. One C, 2C, 3C. Okay, so you can see why it's important to put these labels here in column A. It really helps you when you have a lot of variables. Okay, now we're ready to go to data, solver. Our objective is in B19. Okay, now this is cost, so we want to change it to minimum. Okay, our decision variables are B19 to B17. Okay, now our first constraints are less than. 1, 2, 3 are less than 1, 2, 3. Okay, now the 3 stores are equal to, so the 4, 5, and 6 equal to 4, 5, and 6. Okay, and we need our decision variables, B9 to B17, greater than 0. Okay, solve, okay. Okay, now let's look at this right here, okay. E to the negative 14, what that means is move the decimal left 14 times, so you end up with a bunch of zeros like that. Okay, I didn't count there, but you would have this whole bunch of zeros there. So what that means is, okay, oh, I almost had enough. What that means is that's pretty much zero. Okay, so that's practically zero. Okay, so it looks like we're going to only have a few routes where we send some TVs. Okay, and our cost is $7,300. So we're just going to send some TVs from warehouse 1 to C, from warehouse 2 to B, from warehouse 3 to A, and from 3 to B. So we're not doing all the routes. Okay, that would cost too much. Okay, so we're trying to find the best routes to send our TVs to our stores. And that's the end of this lesson.